we have an exemplary RL circuit, one coil here, a few resistors, and switch which is opened at t equals 0. Our task is to find this voltage across the switch after its opening, and also voltage across a coil after opening the switch. On this slide we have a simulation results based on manually prepared a netlist. In such case, to model a single element switch, we need 1, 2, 3, 4 lines. This is a model of the switch. Then we need also to include a voltage source, a resistance, and this switch is controlled by this voltage. So as you see, it is quite complex to model a single switch, 1, 2, 3, 4 lines. It is much easier in case we have a switch or switches in a circuit to apply a schematics version, because in schematics version we already have in a file, in a library, we have two switches, T open and T closed. So switch is part of circuit diagram. We may find this switch in this browser. Then we may set values for this switch. Transition time 1 nanosecond looks to be a safe value. Closed resistance and opened resistance 1 megaohm should be 1 megaohm should be enough. Then setting of analysis, the transient analysis, well, 10 milliseconds is the final time. After saving this data, we may start a simulation. At first a black window appears, then we may add traces. First trace is a voltage across a coil, and the second trace is a voltage across the switch. We have to recall a netlist to know what are numbers of nodes. So this node is number 3 and this node is number 2. Number 2, it is automatically assigned by schematics. So now very briefly a live version of this simulation. A circuit diagram already stored in computer memory, so we have a switch which can be found in this browser. Values of the switch, the time when the switch is open is 0, transition time 1 nanosecond, and closed open resistance. Each time we set a value, we have to save this attribute. Transient analysis setup 10 milliseconds, no need to give any step ceiling here. Okay, we are saving this data, and then we click simulate. Simulation starts and simulation is completed. Now we have a blank window. We have to add traces, trace, add trace. So at first voltage across a coil, which is V of node number 3, and then we may add another plot, and above we have a voltage across the switch, add trace. So it is a voltage of node number 2 minus a voltage of node number 3, and this is voltage across the switch. That way we have a completed simulation using a PSpice schematic. Let me repeat, if we have switch or switches, it is recommended to use this version of PSpice.